researchers have predicted the existence of a new state of matter, which is created through the action of a particle known as the hourglass fermion. In this state, particles are thought to flow through channels in a pattern that resembles an hourglass, also called a dispersion. Channels of this kind were previously unknown, and though the work is still theoretical, but researchers say it could point to a new state of matter. The researchers at Princeton University propose the idea that hourglass fermions can exist in crystals made of potassium and mercury combined with antimony, arsenic, or bismuth. The crystals act as insulators in the interiors and on the top and bottom surfaces, but conductors on two of the sides. This creates the hourglass-shaped channels, through which electrons flow. Researchers have grouped this theoretical particle into a family of materials known as topological insulators. In this, the bulk of the material acts as an insulator and blocks the travel of electrons, while the conductive surface allows them through set channels. Channels of this kind are created by particles known as Dirac fermions. While fermions are subatomic particles that can include electrons, protons, and neutrons, they can also be found in nature in lesser forms, massless Dirac, Majorana, and Weyl fermions. In the recent work, the researchers theorize that the laws of physics allow electrons to flow on the side surfaces, while the laws of physics prevent them from flowing elsewhere. And, they say the dispersion feature could be seen in other materials. Our hourglass fermion is curiously movable but unremovable, said Andrei Bernevig, associate professor of physics at Princeton University. It is impossible to remove the hourglass channel from the surface of the crystal. Our work demonstrates how this basic geometric property gives rise to a new topology in band insulators, said former graduate student Iris Alexandra Donata. Surface bands connect one hourglass to the next in an unbreakable zigzag pattern. The researchers were able to draw connections between the theorized system and high-level mathematics. In a field called cohomology, there are 230 crystal types which can exist in nature. The team says that 157 of these crystals are non-simorphic, which means could potentially exhibit similar hourglass behavior. The hourglass theory is the first of its kind that describes time-reversal symmetric crystals, and moreover, the crystals in our study are the first topological material class which relies on origin-translating symmetries, said postdoctoral researcher Zijin Wang. According to the researchers, these properties could have a host of electronic applications, including efficient transistor switching. The exploration of the behavior of these interesting fermions, their mathematical description, and the materials where they can be observed, is poised to create an onslaught of activity in quantum, solid-state and material physics, said Robert Kava, Princeton's Russell Wellman Moore Professor of Chemistry. We are just at the beginning.